Hello there. Here's your geometry lesson for section 5.5, Inequalities in One Triangle. Missy McCarthy, Okemos High School math instructor. In this particular lesson, there's only one objective, and that's for you to be able to apply inequalities in one triangle. There is another portion to this section about indirect proofs, but we're not covering that piece. The only thing we're covering is the inequalities in a triangle. Okay, so let's explore just a little bit before we get started. Given side lengths of 9 centimeters, 5 centimeters, and 2 centimeters, can a triangle be formed? Is that at all possible? Okay, well, what I'm going to do to explore this is to take one of our compasses, safety compasses that we use in class, and I am going to draw a segment right down here that is 9 centimeters long. So I have this safety compass on the screen, and it's moving, and yeah, that didn't work out very well. Let's try that again. So starting here at 0, going to 9. Yep, so that segment right there is 9 centimeters long. So it doesn't say what the angles have to be, but I just have to have two other segments that are 5 centimeters and 2 centimeters. So I'm opening my safety compass up now. I'm moving the slider down so that it's 5 centimeters. I am going to put the center of the safety compass, or the spinner, right here on A, and I'm going to make an arc that is 5 centimeters. Okay, so let's try that again. Again, the computer is more slippery than paper, so it moves a lot. There we go, that was a little better. So no matter where I draw, if I go from A to here, or from A to here, or from A to here, no matter where I go, all of those segments are going to be 5 centimeters long. Now if I want to do one that's 2 centimeters, I'm moving my slider so that it's in line with 2 centimeters. I am now placing the circle part of the slider right here on segment B, so it's there, and I am going to, if I can keep it from moving, place it right here and make my arc. So again, no matter where I draw this arc, if I go here or here or here, everywhere it's going to be 2 centimeters, because I could go all the way around this whole thing with a circle to 2 centimeters. So if we were to draw that segment in, let's go to our first arc here. That's a 5 centimeter segment. And if I were to draw this guy in here, that's a 2 centimeter segment. Okay, are those guys ever gonna meet to form a triangle? Right now they definitely don't meet. I could come in here and they wouldn't meet. I could come here and they wouldn't meet. I could bring this guy in here and they will never meet. And so these guys cannot form a triangle. It's not possible. Okay, so how can we check to see whether or not 3 sides will form a triangle? Well, we have the triangle inequality theorem here that says the sum of any 2 sides of a triangle is greater than the length of the third side. I like to shorten the triangle inequality theorem and say the sum of the 2 shorter sides, AB plus BC, has to be greater than the longer side. Because if we're doing AC and it's the longest and we got BC, it's definitely going to be longer than BA. And vice versa. So I like to say, and this is another way you can phrase it. You can say the 2 shorter sides. I should say the sum of the 2 shorter sides. Sum of the 2 shorter sides must be greater than the longer side, the longest side in any triangle. Okay, the sum of the 2 shorter sides must be greater than the sum of the longer side in any triangle. I don't like those little stray marks. They drive me nuts. Okay, so there we go. So let's go back and see why it didn't work on the other slide. If we look at this guy right here, it did not work because the sum of the two shorter sides, 5 plus 2, that's not greater than 9. Okay? This side couldn't even be 3. It couldn't even be 4. So this side must be greater than 4 in order for this triangle to work. Okay, so that's why it didn't work. So that's what we call the triangle inequality theorem. Now, you may need to use these other two relationships a little bit later. All three relationships definitely work. But the one that's muy importante is this last one here. The sum of the two shorter sides must be longer than the third side, the longest side of any triangle. Okay, so let's try some problems here. Will this triangle be formed given the lengths 7, 10, and 19? Well, you can quickly show that the answer to this is no. And why is it no? Because 7 plus 10 is not greater than 19. So a triangle will not be formed. The two longest sides are not greater. Two shorter sides, the sum of the two shorter sides is not greater than the longer side. Let's try this. Our two shorter sides are 2.3 and 3.1. So 2.3 plus 3.1, is that greater than 4.6? Well, if we add these guys together, we get 5.4, and that's greater than 4.6. So yes, a triangle will be formed there because the sum of the two shorter sides is longer than the longest side. For this last one, they give us expressions, but then at the very end, they tell us that n is equal to 4. So what I'm going to do is I'm going to plug in 4 for n here. That gives me this side of 10. If I plug in 4 here, this gives me 4 squared, which is 16, minus 1, which is 15. And if I plug in 4 here, I get 12. So now those are the three side lengths that I'm really dealing with. So I want to make sure that the sum of the two shorter sides is greater than the longer side. And the two shorter sides are 10 and 12. Is that greater than 15? We get 22 is greater than 15. So yes, indeed, a triangle will be formed there. Okay, other angle relationships in a triangle are listed here. It says if the sides of two triangles are not congruent, then the longer angle is opposite the longest side. If in a triangle, the larger angle is opposite the longer side. We already know that about right triangles. We said the 90-degree angle is the biggest angle, and the hypotenuse, which is across from the 90-degree angle, is the longest side. And so they're just reiterating that point for any triangle. So in this case, they're saying if segment AB is longer than segment BC, then that means that the angle across from AB, so angle C, is bigger than the angle that's across from BC, which is angle A. So in other words, bigger side, bigger angle across from it, smaller side, smaller angle across from it. Simple as that. So we can use that to write the angles in order from smallest to largest. So if we're looking at this particular triangle here, we know that GF is 19.6. We know that GH is 17.2, and FH is 20.4. So that means we can put these in order. This one is the longest, so the angle across from that is going to be, and it says from smallest to largest, so let me write them in order that way. From smallest to largest, so this would be 1, this would be 2, and this would be 3. Now what angles coincide with those guys? Well, for GH, that across from GH would be angle F. Across from GF, GF is right here, so across from that would be angle H. And then across from FH, FH is the longest, so angle G has to be the biggest. So if we were to write those in order, the smallest is angle F across from the shortest side, angle H is across from the middle side, and angle G is across from the longest side. So we just ordered those angles in order from smallest to greatest. So that would be your final. Okay, we can do the same thing with the sides. Knowing that the sides of any triangle add up to 180, we can find the length of that third side by doing our 72 plus 60 and subtracting that from 180, 180 minus 132. So we end up with this side of the triangle here being 48 degrees. And I just used the triangle sum theorem there. So if we were to put those in order, the smallest angle is angle R, the next biggest angle is angle P, and then the largest angle is angle Q. So if we were to put the sides that are across from them, that means that this is the smallest, this is the second, and this is the third. So then the side across from angle R is PQ. So segment PQ would be the shortest. The side across from angle P is segment QR, that's the middle length, and then angle Q is the biggest, so that means the longest segment is segment PR, and those would be the segments in order from the smallest to the greatest, or the longest actually. I should put shortest to longest, smallest to greatest. Alright, so here's the last example that we have to do. The lengths of two sides of a triangle are 8 inches and 13 inches. Can we find the range of possibilities for the length of the third side? There's a number of ways you can tackle this, but I'm going to tackle it using the triangle inequality theorem. So I have a triangle here, and I know one side of the triangle is 13 inches, and I know the other side of the triangle is 8 inches. So there's a lot of possibilities for the triangle inequality, according to the triangle inequality theorem, for this particular side. It doesn't just have to be one thing. Okay, so because I don't know how long it is, I'm going to call it x inches. Now for the triangle inequality theorem, I know that the sum of any two sides must be greater than the longer side. I don't know what the longest side is here, so I'm going to write all three inequalities. I'm going to say that 8 plus x has to be greater than 13. I know that that's true. I know that 8 plus 13 has to be greater than x. And I also know that x plus 13 has to be greater than 8. Now this one I actually don't even want to use because x can't be negative. It's a side length of a triangle, and 13 is already greater than 8, so that one we can discount. We really don't even need to use it. If we solve this inequality, we get x has to be greater than 5. That'll definitely make, can be one of the sides of the triangle, any number bigger than 5. And if we solve this inequality, we get x is less than 21, because 13 plus 8 is 21. Okay, so that means this side length has to be bigger than 5 and it has to be less than 21. So x has to be less than 21 and it has to be greater than 5. So that's the range of possibilities for the side length of that triangle to form a triangle, according to the triangle inequality theorem.